All right, we are going to kind of put all of this sum and difference and double half angle formula stuff together today. And so we are going to be looking at sort of using those formulas and kind of going backwards a little bit today. So first of all, this one I'm just asking you to write as one expression. And so what you're going to do here in this first section where I ask you to write it as one expression is you are going to find a formula that this matches up to. This is going to be the right side of either a sum and difference or a double angle or a half angle formula. You're going to go back and give me the left side, okay? So I am going to look for a formula that goes 2 cosine squared theta minus 1, okay? And again, it could be a double angle formula, it could be a half angle formula, it could be a sum and difference formula. Probably won't be an identity on these pages, but we'll get to some like that. And here you go. So here's this. You're going to give me the left side, okay? Notice what's plugged in for theta here. That's what's going to need to get plugged in for theta there also, okay? So it is the formula for cosine at 2 theta. So this is the formula for cosine at 2 theta, and then what's plugged in for theta is 13 degrees in this case, and 2 times 13 is 26 degrees. I don't have coordinates for 26 degrees, so I can't find the cosine at 26 degrees, but if you did, if it came out to be like 30 degrees, please find the cosine at 30 degrees. In this case, I don't have coordinates at 26, so I'm going to just let you leave it like that, okay? All right, here's our next one. Oops, that's the same one. Here's our next one. Again, this is either a double angle formula or a half angle formula or a sum and difference formula, something like that. But you're going to look for the formula that is 1 plus cosine at 33 degrees over 2. So you'll go over here. 1 plus cosine over 2 is right here. So this is the formula I'm looking for. I gave you the right side. You're going to give me the left side. What's plugged in for theta is 33 degrees. So I'll go back up here. This is the formula again for cosine at theta over 2. In this case, theta is 33 degrees. And 33 degrees over 2 is 16 and a half. And again, I don't have coordinates at 16 and a half, but if I did, I would want you to find cosine. And so you can just leave it like that. All right, similarly, you're going to look for a formula whose right side looks like this. 1 minus cosine at something, 1 plus cosine at something. So I will go over here. 1 minus over cosine, 1 plus over cosine is going to be right here. So here's the formula. What's plugged in for what's plugged in for theta right here is 120. Okay, so 120 is plugged in here, which means 120 will need to be plugged in there. Okay, so this is the formula, again, for tangent at theta over 2. What's plugged in for theta is 120 degrees. (120 degrees over 2 is 60. And now, since I have coordinates at 60 degrees, I want you to actually find them. So if you want to pull out your unit circles, you can, but 60 degrees, of course, is up here. The coordinates at 60 degrees are 1/2 and square root of 3 over 2. Tangent is your y value over your x value. So tangent will be root 3 over 2 over 1/2. Flip the 2 over the 1. The 2's are going to cancel, and you will get root 3. So I want you to have root 3 as your final answer here since you have coordinates at 60 degrees. All right. 1 minus 2 sine squared at 18. I think you're getting kind of the gist of this, but you're going to look for a formula that's 1 minus 2 sine squared of something. So that would be right here. So that's the formula for cosine at 2 theta. What's plugged in for theta is 18 degrees. So you'll go back here. Again, this is the formula for cosine at 2 theta. What's plugged in for theta is 18 degrees. And 2 times 18 is 36. Okay? Don't have coordinates at 36, so I can't do anything. All right, here's another one. Sine cosine with a minus sign in between, and then cosine sine. So we'll go over here. Sine, cosine, minus sign in between, cosine sine. So it will be the formula for this. Okay, there's the right side. The left side of it would be sine at alpha minus beta. Okay, so that's the formula you're going to use. So this is the formula for sine at alpha minus beta. Sorry. Sine at alpha minus beta. Alpha is 50 degrees, beta is 20 degrees. Okay, 50 minus 20 we know is 30. And again, since you have coordinates for 30 degrees, I want you to actually find sine. So 30 degrees is over here. Your coordinates are root 3 over 2 and 1/2 if you're looking at your unit circle. Sine is your y value, so the answer for this would be 1/2. All right, kind of moving on now to some proofs, which I know look scary, but these are all ones that involve just quick formulas that you just sort of have to prove. Okay? Again, you're going to use sum of difference formulas, double angle formulas, half angle formulas. So I need you to prove this, and basically you're going to turn the left side into the right. So I want you to realize that this, and again, you can't move anything across the equal sign. This is the formula, if you look, sine cosine plus cosine sine. This is the formula right here. I gave you the right side. This is the formula for sine at alpha plus beta. Okay? So if I go back up here, this is the formula for sine at alpha plus beta. What's plugged in for alpha is 6x, and what's plugged in for beta is 2x. And 6x plus 2x is 8x. Okay? And now I've turned the left side into the right. All right, this one I'm actually going to go backwards on, and I'm going to turn the right side into the left. Okay? So this is the formula for, if you look, this is the formula for cosine at 2 theta. So this is the formula I'm looking for. Okay? Now, here's what I want you to notice. Right here, we have theta. Okay? And right here, we have theta. But it's going to be a little bit different when we come over here. So, our formula says this, 1 minus 2 sine squared theta. This is what our formula says. And you don't even need to write the step for me, but I'm just going to do it so you can see it. And then it's cosine 2 at theta. Okay? But here's the difference. Instead of theta being right here, it's 4 theta. So I need to take 4 theta and think about if this was 4 theta right here, I would also have to put 4 theta right there. Okay? So you don't even need to show me that piece of it. All you really need to show me is this. This is the formula for cosine at 2 theta, and what's plugged in for theta, instead of theta, it's 4 theta in this problem, and 2 times 4 theta obviously makes 8 theta. Okay? And that's what I need to see is the piece in black. All right, a couple more. This is a little different because it is sine to the 4th minus cosine to the 4th. What I want you to think about is that this actually is a perfect square, so you actually have to do a little bit of math here. And this can factor as sine squared plus cosine squared theta, and then sine squared minus cosine squared theta. Okay? Well, sine squared plus cosine squared theta is an identity, and that piece is 1. So I have 1 there. And then obviously I have sine squared theta minus cosine squared theta left. Okay? Sine squared theta minus cosine squared theta. If you go to your formulas now, sine squared theta minus cosine squared theta, let's see, sine squared theta is it cosine squared theta minus sine squared theta? No, sine squared theta minus cosine squared theta. Okay, if I look at where I'm at and where I need to be, I'll notice that I have to have all sines in the end, but I've got this oddball cosine form, or cosine right here. Okay, so what I'm going to do is I'm going to replace that with its identity. And if I look over here, cosine squared is the same as sine squared, or 1 minus sine squared. Okay, so I'm going to replace cosine squared with 1 minus sine squared. Okay, and then I'm going to distribute this negative through. Okay, and then sine squared plus another sine squared makes 2 sine squared minus 1. And I'm where I need to be. All right, another one, you guys. Okay, you're going to use this formula right here, and you're going to look for something pretty similar to it. If you look over on your sheet, you have the formula for cosine squared at theta minus sine squared at theta, and the other side of that says cosine at 2 theta, just so you know. And again, I don't need to see that piece in red. I'm just trying to show you this so that you can kind of picture it a little bit better. Notice that these are 2 thetas right here. Okay, so that means that 2 thetas need to be plugged in here, need to be plugged in here, and need to be plugged in here. Okay, so what I really need to see is this. This is the formula for cosine at 2 theta. And then in place of theta, in our formula, normally it has theta right here, but in this problem, it has 2 theta right there. So that's what I need to plug in on the other side as well. So 2 times 2 theta is 4 theta. Okay, and now I've turned the left side into the right. All right, and you are going to get a worksheet for homework, and we will see you next time.